All right, let's go to number 11 now. Oops, what's that mess? I forgot to change this thing up here. Change that to that, that to that. Okay, here we go. Now we're ready. Number 11, where are we at? Right triangles again. No yawning. All right, here's this triangle. This is 45. Ah, this is, now look at the instructions. The instructions say the answer should be exact and simplified, which means you're not going to use a calculator for this stuff. Okay, no calculator for this. You need an exact answer. Watch how easy this is. You will be amazed if you got it wrong earlier how easy this is. You just have to remember something, okay? And it comes down, Ravon, you were saying, if you can just remember your formulas, you should be good to go, right? And this is something that you have to memorize. It takes time, it takes effort to sit down and memorize these things. So the hypotenuse is equal to the square root of 2 times one of the legs. That's on which type of triangle? 45, 45, what? 90 triangle. Don't use a trig function on this. If you use a trig function on this, you could technically find this answer right here. But it won't be an exact answer. It'll be an approximation because you're using your calculator, okay? I want you to do this without a calculator. I'm trying to force you to learn how to do these things because when you take the SAT in preparation for college, you're going to have several problems on here. Because the SAT is a lot of problems. It's not like that little achievement test you take in regular school. You know how you finish with like 20 minutes left and you sit there, there's nothing to do? You ever do that?
Yeah.
Have you been taking those achievement tests? Probably when you're younger. Okay. But the PSAT and the SAT, you don't have that kind of time. I mean, you have to finish you can't spend a lot of time on one problem. So if they give you something like this, don't waste your time doing the trig functions. Look at this and say, oh, it's 45, 45. The hypotenuse is the square root of 2 times one of the legs. So here's the answer. 16 times the square root of 2. I'm done. Go on to the next one. Do you see that? There was no math involved in this at all. This was a very simple problem. It was simple if you knew this. If you didn't know that, it wasn't simple though, was it? All right, so that's what you have to know. Everybody got that? All right, look at number 12. 12 is kind of the same deal. This is a 30, 60, 90 triangle. And again, you have to know stuff. You got to memorize things. Believe me, I have you memorize a whole lot less than what some teachers have you memorize. There are geometry teachers out there that make you memorize every theorem, and they'll say, write out theorem 8-7, and you have to write it word for word. I know that there's teachers out there that do that kind of stuff. I've heard stories. Okay, to me that's ridiculous. I don't think you really learn anything doing it that way. But you could sit there and memorize stuff, but that doesn't mean you'll learn anything. I want you to learn stuff, not just necessarily memorize a whole bunch of stuff. I want you to know how it works. Okay, so here we go. This is 30. And that's a 90, so this has to be 60 degrees right there. We have two things to remember for this. Let me write both of those things down. The hypotenuse. Remember, we have a short leg and a long leg. Which one of these is the short leg?
9.
The 9, because it's opposite the 30 degree, the shorter angle. Right. This is the longer leg, and of course this one right here is the hypotenuse. The relationship is this. The hypotenuse is twice the short leg. And then the long leg is square root of 3 times the short leg. There's no way getting around memorizing this if you're gonna do it. It's really not that hard once you get used to the relationships here. Now look, the nice thing about this problem, it was just as easy as this one because they told you the short leg. When they tell you the short leg, that's a piece of cake. It's easy, especially if you to find either one of these. Now look, the long leg is this one right here. So the long leg is what? It's the square root of 3 times this. Or we write the whole number out in front, just 9 times the square root of 3. That's it. I didn't have to do any math. I didn't have to use a calculator or anything. That's an exact answer, and it's all the way simplified. Just like that. Just taking the short side, sticking a square root of 3 next to it, I got the long side. What if they asked for the hypotenuse? We'll call it y. They didn't in the test, but what if they did? What would that be? The hypotenuse. What if they asked for the hypotenuse?
18.
It's 18. How'd you get 18 that quick?
2 times.
That's right. You take the short side and you double it, right? The short side times 2 is the hypotenuse. So if I take this and I double it, I get 18. If I take this and I multiply by the square root of 3, I get this side right here. It's as easy as that. It's not bad, is it? All right. Go back on the YouTube videos and watch them. I actually got a couple comments today. I'll show them after I'm done here. Actually, I had somebody comment, and if they're listening, shame on you. They said bad word. I don't know if they called me that or they were asking if I was that or not. But they put N-word, right? But they didn't say N-word. They put the word out. And then they put question mark. I erased it from my comments. And they put question mark. So I don't know. Yeah, that's all they put.
They just put N-word.
I don't know. Maybe they think I'm a brother. And so maybe I sound cooler than I thought I did. I don't think I do, though. I still think I sound like a nerdy white guy. So, but anyway. I don't know. That makes me mad. So I erased it as soon as I saw it. It makes me mad. Okay. So here we go. Say what? I know. I told them. I said if they're listening, shame on you. I told them, didn't I?
Oh yeah, you rock with me, man. Yeah.
But I did have a couple nice comments, so that was nice.
14.
All right, this is not quite as easy as the other two. This one you have to think a little bit about this. This is still a 30, 60, 90, isn't it? So the 7 is the which side? It's the long side, okay? Let me write that on there. That's the long side. The x is the hypotenuse, okay? Now, do we have a direct relationship between the hypotenuse and the long side? No, look. I don't know the hypotenuse is anything to the long side, do I? All right? What do I have to find? I got to find the short side. So that's, I'll just keep that in play there. So you have to find the short side. It doesn't say you have to in the problem, but you should know in order to find the hypotenuse, you need the short side. Am I right? See, look. In order to find the hypotenuse, I need the short side. So how do I find the short side if I know the long side?
You do math.
You do the math. Okay, so watch. We're going to use this thing right here. The long side is the square root of 3 times the short side. So the long side, which is 7, equals the square root of 3 times the short side. So how do I find the short side here? We've done this before. This is not the first time you've seen this. I divide by the square root of 3. Divide this by the square root of 3. All right, that's the short side. It's 7 divided by the square root of 3. It's not my answer, though, is it? Because I'm trying to find the hypotenuse. How do I find the hypotenuse if I know the short side?
It's 2 times the short side.
That's right. So multiply this by 2. That's not hard. Watch. 7 divided by the square root of 3. If I multiply that by 2, I get 14 divided by the square root of 3. But am I going to let you, the problem says to simplify your answer. Is this simplified?
No.
Why isn't it simplified? That's right. You can't have the square root on the denominator. So how do I get rid of it? Like that. Okay? That's what you have to do. I even underlined simplify, didn't I? And exact. I underlined them so that you knew exactly what I was talking about. And I took off if you didn't do it this way. So what do we get? We get 14 times the square root of 3 over just 3. That is your answer for x. That's what this length is right there. It's 14 square root of 3 over 3. It has to be this. I didn't accept any other option. Even if you wrote it like this, I did not give it to you because it's not simplified. I told you specifically when we were going over this stuff before we even took the test that you're going to have to be able to simplify this. We've talked about this on several occasions. Go back on the videos and look, and it'll be on there. Take pass. Okay? All right, let's move on. That was number 13. 14 and 15 are real simple too.
I did get that, but then I asked him, you made it all simple for me.
Of course. Okay, here we go. They tell you this is 9, 12, and 15. And this is number 14 and 15. So watch, number 14 just says find the sine of A. It doesn't ask you to find what angle A is equal to, does it? I need to put some letters in here, I guess, don't I? This is A, B, and C. All right, so just find the sine of A. Well, what are your trig functions? What are the so, ka, toa, right? So, did you write that down on your test? So, ka, toa. So we're finding the sine. So it's the opposite over the hypotenuse. So look, so the sine of A is equal to the opposite. Here's A right there. Which side is opposite angle A? 12. Which side is the hypotenuse? 15. Okay. Now, If you left it like that, I gave that to you. Because this problem doesn't say to simplify, does it? All right, I gave it to you if you put this. But you should simplify it, okay? 3 goes into both of those 4 times, 5 times. So you should write it like this. I accepted either one, though. But if you wrote it as a fraction, if you wrote 0.8, would I give you that? Why not? That's right. What does it say? Look at the problem on the test. It says write it as a fraction. Okay, so that would have been wrong. I don't think anybody actually did that, but I would have marked it wrong if I would have seen that. Because it says specifically in the instructions, write it as a fraction, doesn't it? Okay? So you wouldn't blame me, right, if I marked it wrong if you put 0.8, because the instructions say write it as a fraction. Shouldn't you follow the instructions? Absolutely. All right, let's find the tangent of C. Now this is angle C, this one right here. So it's opposite over adjacent. So opposite is 9, adjacent is 12. Reduce it, 3 over 4, and that's as quick as it is. Look, those last, well, at least 4 of the last 5 problems probably took 15 seconds at the most. 4 of those last 5 problems took 15 seconds, so 4 problems you should have been able to do in a minute or less if you knew what you were doing. Okay, would you agree? Because there really wasn't any math involved. Here's the ones I'm talking about. This one right here. You should have known that this was the square root of 2 times 16. So boom, you just write it down. No math involved. This one right here. You should have known that the long side is the square root of 3 times the short side. So you put 9 square root of 3. Bang. How long has that taken? I even explained it and everything, and it didn't even take 15 seconds. Now that one took a little time. I said 4 out of the last 5. Okay, but this one, bang, you look at it. Oh, opposite over adjacent. Takes you 5 seconds to reduce it. You're done. You see it? Same thing here. So really, there are some problems that take a little bit longer, but those problems right there kind of made up for those, don't you think? And they should have been really, really quick. The problem is, if you didn't know what you were doing and you didn't know the relationships, it's not going to be that quick. So you need to know those relationships. All right? Let's keep going. I think we'll actually finish this today. So this is x, this is 7, this is 37. Now this is going to take considerably longer than 15 seconds, but it shouldn't really take any more than a minute. Let's take a look at this. This is a right triangle. Man, the day before the test, didn't I say over and over again that if it's a right triangle, don't use law of sines. Remember, Scrappy and I kind of had it out a little bit, right? Don't use law of sines. Don't use law of cosines, even though you possibly could use one of those. The easiest way to do this is to use your trig functions. All right, so let's use it. Here's 37. Look what sides I have. I have opposite and I have adjacent. Which trig function uses opposite and adjacent? It should be memorized by now. Tangent, right? So you use the tangent of the angle equals the opposite over the adjacent. Look how easy the math is on this particular one. Multiply both sides by 7, and then you just throw that into a calculator. Does somebody have that answer? I don't have my actually, I have it. What number is this? 16. So it's 56.5. No, I'm sorry. I'm looking at the wrong one. What am I looking at? Am I looking at the right test? Oh, I'm looking at a completely different test. What's that? I gave a little bit of extra leeway on some of these, okay? So some people just put 5 and I gave it to you, even though I harped on this yesterday. Look at the instructions. It says find x, but then what does it say? Round the side measures to what? The nearest tenth. Okay, so if you just put as 5, is that rounded to the nearest tenth? No, but I was nice to you, okay? I was a little bit lenient on that, and I'd let you get away with it, even though I shouldn't. It says round to the nearest tenth. It should be 5.3. That's what it should be. All right. All right, 17. Let's do that. It's still a right triangle. So if it's a right triangle and they give you an angle, then we're going to use a trig function. Actually, they don't give you an angle. They ask for an angle, and they give you a couple sides. They give you this and this. This one's a step more difficult than this because we're finding an angle. What are we going to have to use when we find an angle? Use the... No, we have a right triangle. We're going to use this trig function. Give me one word. We say this all the time. If we're trying to find an angle, find the inverse, right? Find the inverse, okay? So that's what we're going to... As soon as you see that, you're thinking, oh, inverse. Aren't you? Okay, well, maybe you weren't, but you should be, okay? All right, so let's do this. So Look at the two sides. Look at this angle. What is this side? This 4 to this angle. It's adjacent. What is this side? Which one is adjacent to hypotenuse? Which trig function is adjacent over hypotenuse? Cosine. So it's the cosine of x is adjacent over hypotenuse, which is 4 over 10. Now look, this is not that hard. Get rid of the cosine by taking the inverse of it. We've done this so many times that should just be second nature to you at this point. And then you throw that into your calculator, and you should get 66 degrees. Why didn't I round this to the nearest tenth? Because it's an angle, and it says round the angles to the nearest degree. All right, so we don't round this to a decimal place. We just keep it 66 degrees. Now, if you would have put a point something, I'll get to you in a second. If you would have put a point whatever, I let you do that. I probably shouldn't have, because the instructions say to round to the nearest degree. I took it easy on some of you guys on a few of these things, all right? But make sure that you read instructions next time and do what I ask. All right, Kenny, you had a question.
How do you like actually do like cosine and sine and tan? Like, how, like what's the actual steps?
What do you mean the actual steps? Like, how do they get those numbers? Long story. We don't have time to go through that. But it used to be back in the day before, like when I think when I first started doing this when I was in high school, they had just started coming out with handheld calculators. So definitely not, I don't even think I had one in high school. So if I had one, maybe it didn't even have the trig functions on there or something, because they were kind of expensive when they first came out. I mean, those little TI-30s that you have now, back when they first came out, they were probably well over $100 for something like that. And $100 back then in the 70s and 80s was a lot more than $100 is today. So if you compare it to prices today, I would say $200-300 right in comparison. So not hardly anybody had one. I sure didn't have one until I was in college. That was my big Christmas present one year. It was the year before I went to college. That was my big Christmas present, was to get a little handheld calculator with the trig functions on there, because I was a math major and my dad figured I'd need one of those, and I did. I used it all through college. Even used it, I think, when I was first started teaching and stuff. Yeah. Well, yeah, we still use trig functions, but here's the story. What they would do in the back of the book, they'd have tables, and you'd have like 4 or 5 pages worth of these tables. You'd have sine, cosine, tangent. Then you have all the angles. You'd have 0 all the way up to 90, and 0, 1, 2, 3, 4, 5, 6, 7. And then they would give you a 4 decimal approximation for each angle. All right, and then so you'd have to flip in the table, look at that number, and then use that number. Okay. So like right here, what you would have done is you would have gone 4 over 10, which is 0.4. So you'd look in the cosine column. So there would be a cosine column. You have all these decimals, 0.0001. You'd have 0.0012 or whatever, 1, 2, whatever. Can't write. But then you would look, and then over here it would tell you what angle corresponds to this. So you'd find that decimal, you look over, and you get something close to 66. That's the way that we used to do it. Okay, but now you have calculators and it's much better. So talk to Mr. Jackson. I never use these things, but it's called a slide rule, and it's pretty interesting thing. My dad was a teacher for 37 years, and he always carried a briefcase, and I'd watch him when I was a little kid grading papers and stuff every once in a while, and he'd always pull out that slide rule. I'm like, Dad, it kind of looked kind of cool. And I'm like, Dad, what's that doing? He'd try to show me, and I didn't really care that much. I cared enough to ask, but then when he was really showing me how to do it, I really never learned it. I wish I would have. But Mr. Jackson used a slide rule when he was in probably high school and college and stuff like that. And but it's a pretty cool thing. It's a pretty cool device, that slide rule. Unfortunately I don't know how to use it, but you can do a lot of that trig stuff with a slide rule, and you can do a lot of like longer multiplication, but you definitely have to know what you're doing. It's not near as easy as the handheld calculators. So you should be very grateful for what you have. And just think, in 20 years, if you ever become a teacher or you talk to your kids about, oh, back when I was in high school we only had a whatever, who knows what the stories you're going to be telling in 20 years are, and that's kind of interesting. They could be. In fact, you bring up a good point about the phones. Listen to this. I've been reading some stories and stuff where they're actually doing a lot of interactive stuff. Is that right word? Interactive, yeah. Between the students and the teacher, using their cell phones. Like they can answer questions in class, using an app with their smartphones. I mean, just all kinds of crazy stuff. So it's getting to that point where, well, I mean, you could stay home now. I got put everything on YouTube, right? And I put all the worksheets on there, right?
There's a thing called K-12, which is internet, kindergarten all the way through 12th
Right,
grade.
yeah. Well, I mean, look what Khan does. All right, we got to finish because I said we're going to finish this before class was over, so we need to finish. This is number 18. Now, this is not a right triangle, so we're not going to use a regular trig function. So we're going to use Scrap's favorite stuff, which is what? Law of sine and law of cosine. So look, I know this angle. I know the side opposite the angle. That tells me what am I going to use? Law of sine. So let's use that. And I'm going to use these two as well. Do you see that? I'm trying to solve for x, so I like to put the x on the top. So I'm going to put x over sine of 80. Now, if I put the side on the top, what am I going to do with these two? I'm going to put 12 on the top, right? Over the sine of 40. That confuses you?
Yeah, like when you put the numbers on top.
Well, just look to see what you're solving for. I always put the variable on the top. It just makes life a lot easier. For you, too. Okay, I'm telling you, for you, too. Make sure you don't have to do it that way, but I think it's easier putting the x on the top. Look, you don't have to. Okay, and I said that over and over again. You don't have to. It just makes it easier. Look. Now all I have to do, since x is on the top, all I got to do is get rid of the sine of 80. So I multiply this by the sine of 80, multiply that by the sine of 80, and now I just put all this stuff in my calculator, and I should get 18.4 if I put that in a calculator. You could put the x on the bottom. Look, if you put the x on the bottom, what would you do? You'd go like, what, sine of 80, right, over x equals what? Sine of 40 over 12. That would not be wrong. Kenny, you watching? You could do this, but then guess what you're going to have to do? You're going to have to cross multiply. So then you would go x, I want to prove to you why my way is better. And then you do this. Everybody see that? And then what do you have to do? Divide by the sine of 40. So then you got to come over here and divide by the sine of 40. But look, it's the exact same thing as what I did right there, isn't it? And I did a whole lot less work this way than I did this way. I think it's easier to put the variable on the top, no matter if you're solving for the angle or the side. Have I convinced you or not?
Yes, you
Okay, good.
I still say the way I do it is easier for me.
All right, that's fine. If that works for you, then do it that way. I'm just trying to help you out.
I get you.
All right, 2 more problems. We're almost finished here.
Law of cosine.
All right.
Yeah.
This is 103. This is 13. This is 20. And this is x. Okay, here we go. Look, let's say law of sines was your favorite thing. And you're like, man, I'm using law of sines every time. I don't care what he says. Could you use law of sines on this? You couldn't, because look, you know the angle and the side opposite, but you don't know any angles opposite these two sides, do you? So you couldn't use law of sines if you wanted to. So you need another way. Can I just use sine, cosine, tangent? No, because I don't know if it's a right. I know for a fact it's not a right triangle because I have an obtuse angle here. All right, so the only other option is law of cosines. This works perfectly for law of cosines. Let me just write it out. It's x squared equals 13 squared plus 20 squared minus, whoops, sorry, forgot something. What did I forget? 2, right, and then 13, 20 cosine of the angle that's opposite x, which is 103. So basically, this is just plug and chug, isn't it? There's no algebra involved or anything. This is just plugging into a calculator. Make sure, though, what? You put a parentheses here and here. That's a real big thing that you need to do. Once you get all that stuff, take the square root, and you should get about 26.2. All right, and that should be your answer right there. You put it in the calculator yourself. We've done that enough times, don't you think? All right, one more. Look, did you notice 20? Did you notice it was just like the problem we did the day before? Remember the word problem about the, what was it, the cell phone tower or something like that? It's the same exact problem, except I said flagpole, okay, and I've changed the numbers. But it's the same thing. Now, I did mess up a little bit. Did you see where I messed up? I put 70 away from the what? The tower. Because what I was doing, I was looking at the problem in the book and typing the stuff, but I replaced tower with flagpole, and I forgot to put... I forgot to replace that other tower with flagpole, and it says tower. So sorry about that, but it still works out the same. So watch what we have. Here's a flagpole. You guys watching? This isn't hard at all. There's a flagpole. I'm not even going to draw a flag on there. It just says a pole, right? So who knows? There might not be a flag on there. She walks, Jen, walks 70 feet away from the pole. You guys watching? Kenny, did you get this problem right?
Yes, I did. 93 feet.
You sure? Okay. So look. Still, other people might not have, so you need to hush. So watch. She went 70 feet, until she looked up, and what was the angle? 53 degrees, so maybe about right in here. Okay? So here's your picture. Here's the flagpole, and you're trying to find out how tall the flagpole is, so we'll make that X. She walked. Are you watching? A lot of people aren't looking. Okay? Look, here's the flagpole. She walked 70 feet away. So what is this length down the bottom? 70 feet. The question says, how tall is a flagpole? I've had people do this. And if you're one of them, sorry, I'm not pointing out because I can't even remember who did it. But some people solved for this. They said this was the length of the flagpole. Flagpoles don't look like that. Flagpoles are straight up and down. Okay? This is the flagpole. She walks 70 feet away. She looks up. What's her angle that she's looking up at? 53 degrees. That's all the stuff that they tell you in the picture. Okay? That wasn't so bad. I can't believe how many people didn't even try this problem, even on the corrections. Even on the corrections. And at least if you drew it, then that's good. That's at least a good start, okay, that you try to draw it out. All right? But now, look, this is just like one of those other problems, like number 16 and 17, okay? It's just like number 16, basically. So let's do this. Opposite over adjacent, tangent. 53 degrees equals opposite over adjacent. This works real nice because X is already on top. Rev, you getting all this, right? Okay. You sure you want to be talking through all this? I don't think that's the best idea. So look, this is being divided by 70, so how do you get rid of it? You multiply by 70, chuck that into your calculator, and you get 92.9. I would venture to say maybe 10% of you got that problem right. I didn't count them up, but just by me thinking about how many people got that right, I would say 10 to 20% of you probably got this right. And it wasn't that hard, was it? Do you think it was that hard?
No.
I don't think it was that hard. So there you go. Okay, this is going to be on YouTube. This is the last time we review this stuff, okay? This kind of stuff will be on the final. It'll be on YouTube, so go back and review it when it's time to do the final.